All right, I guess we're here.
We're here. All right. Thank you so much, Brent, for being with us. Um, really excited about this conversation. Brent and I spend usually once a week talking via the LDC, so it's awesome to have you here and just have a focused conversation about your background. So Brent is a space architect, and I'm going to ask you just to kick it off to define space architecture and how you see it as one of the early pioneers in the field.
Sure. There is a global community of people who consider themselves space architects, and we came together in 2002 at the first Space Architecture Symposium to do exactly what you asked, which is to define the field. What do we mean by it? And so the beginning of that couple of page definition is a very concise statement that says it's the theory and practice of designing and building habitable environments for use in space. So, what that means in terms that people might sort of identify with are things like let's use the International Space Station as an example. There's a whole lot of vehicle systems, what NASA calls it, uh, power production, heat rejection, attitude control, reboost propulsion, telecom, all the things that make a space vehicle a space vehicle. Um, those are not space architecture per se, but what space architecture treats is the habitable environment. So, the ISS is as big as a football field, and the whole thing is there to support um, a little cluster of modules that have about the same volume inside as a 777 altogether, that supports a half a dozen people doing research. So it takes a lot of infrastructure to support the habitable environment in this, inherently lethal place, or this permanently lethal place. That's what space architecture is all about. I get maybe one other sentence about its origin. So it people have thought about habitable environments in space for well over 100 years, um, and it got kind of started in earnest in the late 50s and early 60s, of course. Um, those of us that are focused on space architecture kind of came to it in different ways in the early days. And I'll say we found each other just by going to conferences and seeing who was publishing what papers. And so the community kind of uh, arose organically. And then we realized for this to actually be a field, we have to kind of get organized about it. And so, hence everything else, the technical committee at AIAA and multiple conference sessions every year, and a lot of published papers and several books and all that. So, but we just kind of found each other.
Yeah, it makes sense. Yeah. Yeah, it sounds like a scene kind of started to emerge out of the practice of actual space architecture versus maybe the theory around it, or maybe especially the theory around like some of these mega structures that we like to talk about, like the O'Neill cylinders and stuff like that.
Well, in
Um,
some cases, but although I would say that most of us are as motivated by the design of a window or the shape of a hatch opening, um, as we are about the, you know, mega structure kind of aspect. It's a wide open field, and we're just at the beginning of what will be the future history of space architecture. So there's there's more room for theory than there is for practice. Let's put it that way.
yeah. And you've had a really amazing career. I'm curious if you could walk us through how um, how you started to see yourself as a space architect. How did that emerge? Because the field is relatively small or niche. How did you find yourself in it?
Yeah, well, as I said, everybody came to it in their own way. So, my story is relatively unique, and it may be interesting to others. It's maybe also not relevant to anybody else. But um, I I was born the same year as NASA, so I grew up in the '60s with um, the Apollo program and Star Trek and 2001 Space Odyssey. And I just always loved the idea of people inhabiting space. Um, and when I was little, kind of all I really ever wanted to do was build cities on the moon. And I can't really explain why. It just seems super cool to me to have this like underground city that's all like tunnels and spheres and domes. And I was a little kid, so I gravitated to that. However, I sort of never really outgrew it, I guess. I did take a little detour at the end of high school, 1976, when I went to college. It was kind of between programs in the U.S. space program. Skylab was done, Apollo Soyuz was done. Um, the shuttle wasn't flying yet. And so it seemed like not a great thing to aim at space as a career. Now, mind you, I was a junior and senior in high school. So what did I know about anything? But it seemed like maybe not such a good idea. So I went to college intending to pursue my second love at the time, which was architecture. And so I majored in architecture. I discovered art history along the way and majored in that too. I went to graduate school for architecture, and in my first year in graduate school is when the shuttle started flying. And I thought, you know, by the time I'm ready to retire someday, there will be people doing what I had kind of always wanted to do, and I'm going to be really mad if I'm not one of them. So I finished my architecture degree and immediately vectored over and started over in grad school for aerospace engineering, because it was obvious to me that to do architecture in space um, is fundamentally different than doing architecture on Earth, where we have industries and knowledge bases and all that um, to support it. So there's a whole lot to learn to do space engineering. And so I just went back to school and got another degree. So I'm one of the rare ones, I'd say, that has a degree in architecture and a degree in aerospace engineering, which I believe has enabled me to synthesize the two in a very um, informed way. But then it came time to after I got my aerospace degree, now it's time to really get a job. And I was 30, by the way, before I got my first job, because I'd been in school for so long. Um, and I was super fortunate to be able to get a position um, basically as a space architect. Boeing called it a configurator, systems configuration designer. Um, at Boeing, working for Gordy Woodcock, whom a lot of your listeners may recognize. He had been a kind of a hero of mine since I was a little kid, because I'd seen his name in books. And I was really lucky that Gordy was creating a group at Boeing, um, kind of on the coattails of Boeing winning the Phase CD contract for the modules for space station, and they were forming a group called Advanced Civil Space Systems. Gordy needed a configurator, and it was right at the time when I was looking to get hired. So my first job was as a space architect. So I was, super fortunate about that. I stayed at Boeing for 17 years through the ups and downs of all kinds of programs. The first space exploration initiative came and went. Um, um, the dim time in the 90s when NASA was not allowed to use the word Mars in human spaceflight planning. Then that got reversed, in the early 2000s. By the end of the 2000s, around 2010, it was impossible to talk about human spaceflight without talking about Mars at NASA. So all kinds of, cycles. I left Boeing during the Constellation program because I had learned enough about space programs, government funded space programs, to believe that that program was not actually ever really going to happen. And, but it was stressful work anyway. So I left Boeing and went to JPL, decided to get away from human spaceflight as a career. And I just entered the world of space science at JPL. I was at JPL for 14 years. Ended up as a program manager for planetary mission formulation. And then along came a shift in the industry, which was the emergence of, I call it the fourth pole. In addition to academia and government and industrial contractors, there was this fourth pole I called independent space. And Elon was pushing SpaceX, and Jeff was pushing Blue Origin, and Branson was pushing Virgin. And so I had an opportunity to go to Blue Origin and lead the development of all of their in-space systems, the stuff that goes on top of the rocket. So I went to Blue, and I was there for, I think it was 52 months or 53 months, something like that. A little over 4 years. Got a huge amount done there. Created a lot of programs that people may recognize: Orbital Reef and Blue Moon, Blue Ring, Blue Alchemist, several other proprietary ones. And but that was pretty high stress too. And so I retired in 2023. After I got my Medicare card in the mail, I said, okay, it's time. So I retired in 2023. I consulted to AIAA for a year as the space domain lead for AIAA. And now I'd say I'm fully retired. I just dabble in a little consulting. And I'm trying to get time to actually write some books. So in a nutshell, there's 35 years of career.
Yeah, that's amazing. Yeah, so you've really seen the evolution of the space industry all the way from yeah, your time as a kid seeing the Apollo missions all the way to now the commercial space sector. So I want to maybe linger on those like dreams that you had as a kid of a lunar base, because that resonates a lot with what we think about a lot at MoonDAO. Um, and I've heard you talk about kind of the phases of infrastructure that you see kind of developing over time. And I thought it'd be interesting for you to walk through those phases of infrastructure, and the way that you see these things evolving in order to accelerate or one day lay the infrastructure for a permanent human presence on the moon.
Okay. Huge topic.
Yes.
One of my one of my
We don't
favorites,
ask easy
though.
questions.
um, so I I'll answer. Here's I'm going to give a caveat first, which is, as part of my answer, I'm going to critique the way people casually think about their own answer to the question you asked. Um, and by that, I simply mean it's going to take way longer and be way harder and more expensive, with a lot more setbacks and resets than people imagine. One of the things I've seen, I lived it firsthand in phase C of the space station program when I was at Boeing. I lived it through the formulation phase of many, many space science missions at JPL, and booting up our programs at Blue Origin as well. What happens is people, I think, inevitably somehow accidentally slip into a mode of thinking which is unjustifiably rosy. Um, and a place you can see this, which is maddening to me. Well, it's less maddening now that I'm old. I sort of I'm philosophical about it. But
You're not old.
there's our,
You're
well,
not.
yeah, actually. But anyway, in our field, there are the people that, Teddy Roosevelt would say are in the arena, getting, bloodied and dirty and trying to make it happen. And then there's a vast cast of critics who aren't in the arena. They're maybe sitting in the stands and they have lots to say about how the people who are in the arena are doing it wrong.
Hmm.
And most of the commentary we see in the press is like that. It's people fetching about one thing or another, or, all we have to do is X, Y, and Z. However, as we're reminded every now and then, sometimes in a very painful way, space is hard. Um, it, it it's very hard to make things work. It's harder to make them work the same way all the time, and it's super hard to make them work the same way all the time at a price that anybody's willing to pay. That's a really, really hard thing. And I think in the last 15 years, we've seen enormous progress in that regard. And there are different philosophies of how to develop things um, to make them reliable and less costly, but it's super hard. Okay, so let's look at what we've done. Um, I reduce all of the history of spaceflight to essentially two things. One is learning how to get into space and fly around and get back out of space. And the other is how to um, stay in space for a while and live and work there. And so all of the launch vehicle programs in history, including the new ones, the developmental ones that are happening today, are all about that first thing. And the International Space Station and the Chinese space station and the predecessor Russian space stations are all about the second thing. Apollo was an anomaly um, for reasons that I think all of your viewers understand. Kind of came at a premature time in the development of spaceflight. Um, was a political decision, not a technical decision, and all of that. It was kind of out of sequence, is the way my former boss Jeff Bezos would say, out of
Hmm.
sequence. Nonetheless, it was, it was impressive, but it was out of sequence, which is why it was not sustainable or sustained. Okay, so we've 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 learned how to fly in space, and we're learning how to do it with systems that are reusable, so we don't throw them away. We've learned how to build a big thing in space and operate it and live in it and maintain it for a quarter century continuously, which is amazing. What we haven't done is learned how to play in the dirt on another planet.
Hmm.
And so when we get to the surface of the moon, um, the the sheer amount of learning that we have to do is well, it will be overwhelming. Um, and we could articulate all the, aspects of that. Um, uh, in fact, I'm engaged in a National Academy study right now that hopefully the report will do some of that. It will articulate all the things that we need to learn and where to learn them and how and so forth. But it's super hard. And so people kind of don't think about that very much. And the reason this is relevant to the answer to your question is people imagine fundamentally that what we're going to do is return to the moon, um, and this time to stay, right? It's still the same phrase that George H.W. Bush used, back in um, the early 2000s, um, or earlier, actually. But what's in between those two things is a whole lot of learning. So yeah, we're going to get back to the moon. We and others are going to get back to the moon. Eclipse landers are kind of starting to do it. Now it's going to happen with humans. The Chinese are going to do it by 2030. All of those things are going to happen. Those are sorties. That's basically the modern version of Apollo. You plop down, you know, chuck out some payloads, you set up some instruments, you take some samples, you drive around a little bit. That's basically like the Apollo J missions. And just with modern hardware and safety standards and all that kind of thing. Um, the this time to stay part requires infrastructure. So habitats that can last for maybe decades, that are
Hmm.
only intermittently occupied, that work in a gravity field, that are resistant to the infiltration of dust, that can be expanded by connection with other, HAB modules, that are
Hmm.
supported by a permanent power infrastructure, which can be solar and fuel cell storage, or nuclear, fission, um, and supported by some longer range mobility for regional exploration and discovery and operations, like pressurized rovers, like hoppers, ballistic hoppers. Okay, that's not even mentioning ISRU, trying to do stuff with lunar material. So that's just to be there. Okay, that's like space station in a way, but in this environment that is inherently less predictable than Leo, because you're sitting in the dirt. And it's not just any old dirt. This is lunar regolith, which is one of the most horrible substances known, and about which we actually don't know very much, like how to engineer with it or engineer
Hmm.
systems to sit on it and operate in that environment. We're going to be kicking up dust, but we don't really know how to prevent the dust from getting in things. We know the dust is horrible for our lungs and for things like seals and all that, but we don't really know how to keep it out of things. We don't really know how to clean it off. Um, we don't know how to, um, we haven't demonstrated how to operate heavy equipment like for excavation or for lifting and moving modules in an environment where you only weigh 1/6 as much. So, like if you look at any piece of construction equipment on Earth, it's got huge counterweights and anchors, and you're depending on gravity to stabilize those things. Well, on the moon, you've only got 1/6 g. So you probably can't stabilize with weight. You have to anchor, but nobody knows how to anchor in lunar regolith. So almost every aspect you look at requires an extensive amount of experimentation and trial and validation before we actually even know how to design systems that are sustainable, which in turn are required if we're going to, this time to stay. So, sorry, that was very long-winded, but to boil it down, my fundamental answer to your question is there will be a first phase of sheer exploration,
Hmm.
um, with sorties, with robotic assets, with hybrid assets, robotic adjunct machines around humans on sortie missions, to, I hope, a uh, um, an array of locations around the surface of the moon, because they're different in subtle ways and they all have different benefits. It's not all about the South Pole. Um, so there's exploration. Then comes this phase that I call the practicum, where you actually just learn how to play in the dirt without breaking stuff, or you learn how to break stuff and fix it, or you learn how you should have designed it so that you can design the next one better. And that's a lot of experimentation. That, by the way, is my favorite phase, because every day is full of discovery and surprises and trying to recover from things you learn and be adaptable. And it's like that's what humans do. That's what's so exciting about it. Then comes the phase of establishing permanent infrastructure, maybe building up one or more bases and so forth. So I think to get to the point that I thought I wanted to be at when I was 10 years old, which is designing cities on the moon, we have several decades of learning still to go before we can get to that point. And I think it can go quicker or slower depending on how we
Mm.
divvy up the challenge with our partners, how willing we might be to partner with people that we think of as adversaries, um, and how kind of open-minded we are about the nature of this exploration and discovery and this learning. It's all about learning how to operate in a planet surface environment. And all of that comes before the soundbite that NASA uses today, which is, use the moon as a test bed to prepare for human missions to Mars. There are dozens of things that need to be demonstrated to the satisfaction of modern safety committees before we can send humans to Mars. Some of them have to do with playing in the dirt on another planet, which is what the moon is really useful for.
Hmm. Hmm. So, okay, there's so much to dive into there, but what stands out to me is that you actually have gone through this experience of practicum in different environments, and I'm curious, what have you found to be the strategies that help accelerate that process? How would you advise people to navigate those you said decades. Hopefully, it's not. Well, I'm an optimist. I hope it's less than decades. Um, but how would you, I guess, maybe structure a these like low cost ways of making sure we don't do something out of sequence where
Yeah,
we start to
I,
invest too much money into something that might not work.
I
Yeah.
love that question, because it verges on, well, it enables me to be iconoclastic, which I like to do. Um, let me let me start and answer by way of an example. Um, so one of the things that is almost uh, second nature to people on Earth is the behavior of fluids, including water, air, um, how flame behaves um, at sea level pressure and one gravity on Earth, because we grew up with it, right? We know, even from a very young age, we see candles. We kind of know how these things work. Um, we've learned on the International Space Station how flame propagates in micro G. It's not driven by convection, it's driven by fuel. And so flame is spherical, and um, convection does not occur. This is why um, biomedical industries are interested in the kinds of things we can do in microgravity because of the absence of convection. So that becomes a benefit. Okay, well, the moon is someplace in between. It's 1,6G. So there's numerical models about how um, CO2 mixing will occur in a habitat atmosphere. There's models about how flame will behave inside a habitat. There are models about how um, two-phase flow or constricted two-phase flow will function, like in a thermal control loop that
Hmm.
has pumped fluid that also has gases entrained within it. But all of those are models. Nobody has actually tested any of that in a lunar environment. So I would suggest, um, a methodical or systematic investigation, which would require some specialized apparatus, a payload to be developed for this purpose, in which or with which we experiment with fluids of different viscosities and different mixtures, different proportions of gas, pumping at different speeds through different diameters of tubing,
Hmm.
with video, cameras, high-speed video cameras, to observe and do that over a range of these parameters so that we could literally write the book on constricted two-phase flow in a 1,6G environment. Why would you risk the long-term performance of a life support system or a heat rejection system based only on numerical models? Like, so if it were me, if I could wave a wand, I would say on the very first mission, we're going to have this box inside the cabin of, the Artemis lander, and some crew member is going to have time allocated for, 4 hours. I'm making all this up, right? But you kind of get the picture, a 4 hour block of time to conduct this systematic investigation, collect all these data, and then, the PI departments back on Earth will take all those data and then 3 months later produce a chapter, the fluids chapter of the first edition of the design handbook for lunar systems and operations. And you could do that with granular flow, which is going to be essential for all ISRU activities. You could do it with electrostatic behavior, which is going to be essential for dust mitigation. You could do it with human locomotion, both IVA and EVA, which is going to be essential for timeline analyses and, ConOps development and quantification. Like, all of these things that we think we want to do hinge on physical fundamentals that no systematic investigation has ever done. So
Hmm.
I would, recommend um, an investigation campaign, which is all practical. This is applied science that says, yeah, do these things and do them as early as possible in the Artemis campaign so we can literally write the book. Then we'll know how to design stuff that has a chance of lasting for 20 or 50 years, that actually has a chance of meeting the ops timelines that we project, that has a chance of succeeding at, what we want it to do. And to me, that's the fun part, because I guarantee there's going to be surprises along the way. It's going to be, oh, that's how you do a fluid system, for the lunar environment. Well, who knew? And nobody did until we observed it. I would rather observe it in a designed experiment, sort of a workbench kind of environment, than observe it when my life support system isn't working the way it was supposed to, and I have to figure out why.
Right.
So I don't know if that helps, but I think I would, I think that because lunar conditions are not replicable on Earth, um, learning these things has to be done in situ. And we all know from our respective, engineering fields or design fields, numerical models only get you so far. At some point, you have to calibrate and validate the models with empirical data. So we
Mhm.
need empirical data. We can only get it in situ. So that tells me what the highest priority investigations need to be.
Right. Yeah, that makes sense. Yeah. Yeah, I mean, in some ways it is extremely daunting that even basic things that we believe that we have an intuition for, like how fluids or how thermal systems might work in 1/6 gravity. It could work in an entirely foreign way that we would have never predicted. Um,
A good example is, it's a tiny example, but I think it's very sobering and illustrative, is on the Phoenix mission to the North Polar region of Mars. Um, it had a scoop, and part of the uh, investigation was to introduce Mars regolith into the instruments that were inside the lander, Mecca and Tiga. And JPL struggled for, I think it was weeks, to actually get the soil into the input funnel of the instruments. Not because the equipment didn't work, but it was because there were cohesive attributes of that regolith that were not known, and that just made the configuration of the scoop system kind of not let go of the soil. So a few grains went in, but it's like, no, that's not what we had in mind. Okay, that's a really simple thing. And yet here we are imagining we're going to strip mine the lunar mare for helium-3, and we're going to, you know, or like Vlada's team at Blue, you know, we're going to drive along and ingest regolith in the front and poop out solar cells in the back. And okay, we're going to do all those things. I'm confident we're going to do all those things, but not without some discoveries along the way. So I would just like to do the discoveries first, or like as soon as possible, before we spend all the money and all the time on designing systems that are actually not optimal for the environment.
It sounds somewhat reasonable. It sounds somewhat reasonable. I shouldn't laugh at the idea of the grains just sticking, but it's just like it's a great visual of just like our hubris. We're like this should just work easily, but
Right.
just of the unorthodox, or I think it's maybe difficult to build an intuition around how some of these things would work because we just have all these expectations here on Earth. Um,
I am a big fan of what I call I used to call it the Russian approach. It's also the SpaceX approach, which is doing the minimum you have to do in order to get to the place where you can try something, because you know you're going to learn stuff that you could not or did not anticipate, and you want to get to that point of learning as fast as possible.
mhm,
And I thought about this a lot back in the early 90s, when I was on the space station program, because we were going through budget exercise after exercise for years, um, as part of the NASA way, which is designing it all um, in a nice, clean way so that then you build it and fly it and it's going to work. And which is the opposite of the Russian way. You know, the Russians in their space station years just took a module they had, and they put it up, and then they kind of, you know, measured what worked and said, ah, yeah, okay, next time let's tweak this or do that, and then they would do that. So I think we're going to learn either the easy way or the hard way on the moon, that shortening the cycle of experimentation and learning is the smartest thing we could do.
right.
So then at a programmatic level, the question is, how do you structure a program in order to shorten that cycle? What payloads do you put on? What's the nature of the missions that you plan, you know, and the activities that you plan on the very limited sortie EVAs that you have? Um, it should be all about maximizing learning,
Mhm.
and folding that back into the design cycle and the planning cycle.
Right. So I do want to go back. So I find it very interesting in your background that that you saw the requirements of your field as being not just within architecture but also within engineering, and I think that I've always had the I've always felt that it never really made sense to me that you'd have civil engineering on one side and then architecture on the other side, when it does feel like the union of the two is really where all of the magic happens. Um, but I'm curious, what recommendations would you have for people that would want to enter this field now? how do they get the sort of intuitions on the imaginative and design side in order to think through some of these things, but then also still have the technical grounding to be able to actually back that up with numbers, figure out the actual what is just fluff and maybe too out there, and what is actually realistic. How would you navigate that today, say maybe if you were a college graduate?
Yeah. Well, I'll answer the same way that I answer when I'm mentoring college students or grad students or young professionals. There is there is a role for fantasy. I'll maybe start there. There's a role for dreaming and for a kind of um, you could call it a design intention, maybe, that's not based in engineering. Um, I personally have never really been very good at operating in that domain. Um, I personally am much more interested in learning the constraints and then using the constraints to shape what it is that I can actually do. And um, Frank Lloyd Wright said, years ago that constraints are an architect's best friend. Because otherwise, you can have a blank page and you can do whatever you want. But in the real world, you can't. And to your point about the synergy of fields in terrestrial architecture, civil engineers, structural engineers, architects all work very closely together in team-based environments, and that's how we build buildings that are so many stories high on a piece of rock between the East River and the Harlem River. That how can you do that? Well, it's because they work together. um, the same thing will happen on the moon. And my advice to anybody uh, who asks like how they get started is, I always say two things about space architecture. One is get a day job, because the number of paying opportunities to actually be a space architect is very small. And it'll probably be small for a long time. There's more interest than there are openings. So get a day job. Because ultimately you have car payments and mortgage payments, you have to live. Um, the other is to find what is the most fun and interesting aspect and then get really, really good at it. Because um, architecture is it's an inherently integrative, inclusive field that depends on the expertise of specialists. And almost every generalist starts out as a specialist in something or other. Um, I was lucky that I started literally in configuration design, which is the closest thing in the aerospace industry to architecture. Um, but not everybody does or can or wants to. And so you you can you can do space architecture if you're a thermal engineer or a structures engineer or a life support engineer, and or an industrial designer or an interior designer, or a materials scientist. They're all essential. And I personally think the best way to end up in a position of responsibility is to find a talent and develop it into a skill that is needed and that kind of sets you apart from everybody else. Because if I'm putting a team together, I want the world's cleverest industrial designer, and I want, the person who actually knows the most about space qualifying novel materials, and that's who I want on the team. So um, I think there's nothing wrong with getting really good at something and then parlaying that into a career direction. I don't know if that answers, but that's kind
Yeah.
of how I normally, yeah.
No, it makes a lot of sense. Yeah, these projects are a team sport, so you want to have people in each of the roles that are experts in that field, and then through maybe gaining that experience and rubbing shoulders with others, then you start
I,
to maybe broaden out and
I
start to
think so.
merge concepts. Yeah.
I think so. One thing I think I've seen, well, one thing I have seen that I think is not necessarily good in the in this emergent field is um, young people, particularly trained as architects, um, who really want to start off as generalists. They want to start off being like the master designer, um, and I have to say that may be possible in space, but I haven't ever seen it happen in the space field. Um, it's still a very, very engineering intensive field. There is no master designer. There's, there's a team and a process for systems engineering a product that's not going to kill people in this permanently lethal environment with high speeds and high energies and like it's like they say about Australia, but in space, everything really is trying to kill you at every instant. And so I think I think the way to become a respected generalist or integrator um, is not by starting out that way. I think it's by growing into it.
Yeah. Yeah. It makes a lot of sense. So we do have some questions from the community that I want to make
Sure.
time for, and then also just to tell anyone who's watching, if you'd like to write your question, we do see these. You can write your question on any of the platforms, and we'll read them out here. So the first question is from Daniel Tompkins. He asks, the ISS did have plans to be used as a test bed for deep space. CLD doesn't seem to at all. Is this a missed opportunity?
Ah, sigh. Yeah, it is. The it's unclear to me how the CLD program is actually going to come to fruition at NASA. The plans change, and it's a very dynamic environment, and it's competitive all this at the same time that nobody's business case closes, and so it's a really hard thing. I believe that um, NASA has. Oh, sorry for that. I've got a helper. Um, NASA has not um, had the, it's not demonstrated the guts, I'm going to say, to cast into requirements for its use of a CLD or the ISS things it could do that would, in fact, accelerate human exploration. So here's an easy one. Um, NASA wants to send people to Mars. Okay, on a conjunction class mission, that's a 3-year mission, and it's mostly microgravity with 9 months of or maybe a year of Mars gravity in between. So if you seriously thought that's what you wanted to do, the obvious thing to work toward is let's put a crew on a platform in space for the 7 months it takes to get to Mars, then stick them in a module which is being rotated to give them 3 hg for 14 months or whatever the duration is on the surface, and then put them back in microgravity for the other 7 or 8 months to get them home. And if you're not ready to do that, then you're clearly not ready to send people to Mars.
Mm.
And yet we haven't done that. So although I am thrilled to see progress, which is really starting to happen. The momentum is starting to build for progress in biomedical and other uses of a zero-G platform in Earth orbit. It's kind of finally starting to happen. Um, I think we are. significantly under anticipating how we could and should use such a platform to get ready for other things.
Right. Yeah. Something that does come to mind, because you mentioned the Russian approach, right? The simple approach. And I'm not saying that we should do this, but I do think this might end up being the possibly unfortunate, but maybe a possible outcome, is that those first missions might be martyr missions, and those people going might really understand that, hey, we have so many questions or so many things that we really don't understand about this environment, that the probability of people dying on these first missions will be extremely high. Um,
Yeah, the way I view it is a little bit different from that. I think I'd say you just articulated the difference between hope and reality. I view it as the difference between talk and action.
hmm,
I think by the time um, the US Congress is actually willing to appropriate the funds that it would take for government employees to get into a system and go do a Mars mission, um, many of these uncertainties will need to have been resolved. And so
mhm,
I see it as the gap between people casually talking and informed people actually being um, clear-eyed about what the work required is.
yeah,
And I don't think all the advocates are clear-eyed about it. I think there are advocates who are so desperate to fulfill this decades-long dream of humans to Mars that they're suppressing some of the, consciously or unconsciously suppressing some of those realities. I mean, you could ask, why is it that NASA has persisted for decades in saying that we don't need artificial gravity to send humans to Mars? The longest any human has ever spent in space is 1 year. How are
yeah,
you going to do that for a 3-year mission? Who's going to sign on that dotted line?
mhm,
Right. And so I would much rather expose the issues and face them and engineer our way through them than just keep talking about um, or wringing our hands over, why are we not going to Mars already?
right,
Well, there's really good reasons why we're not going to Mars already. And there's really good reasons why Elon is not going to be sending 100 people a week or a day, to Mars. I do think it is conceivable that your concern comes to fruition in an environment that's privately funded. But
mhm,
um, even there, well, Starship is not privately funded. Everybody needs to be clear about that. It's funded as a partnership with the US government. So the US government has things to say about it, as they should. But it's maybe it can land on Mars, but uh, not on a conjunction class mission without a whole lot of stuff that's enabling you to stay there and operate there for, a year and a half or however many months it is.
right,
Um, And if you choose to just do a short stay, like an opposition class mission, well, then you're facing a year and a half in space on the way back, with like a Venus flyby and going to parts of the solar system that nobody is thermally designing their vehicle for. So
mhm,
we're way farther away from it than people think. That's not a bad thing. It's just a
yeah.
thing. We just have to be realistic and honest about it.
Yeah, I mean, if anything, it's a good thing. That means that there's more to learn, more to understand, and more opportunities for people to, yeah, write the book, essentially, like you were
Mhm.
saying earlier. Um, I want to read another question here from Sim Symphony. Sim Symphony says, could a consortia of industry find value in integrating integrated processing systems engineering on Earth in a fully automated ma- mayor, ma-
Maersk.
Maersk
Yeah, shipping
ship
company,
as an analog.
big shipping company.
Hmm.
Um, Integrated processing systems engineering. I'm not clear on what symphony means by that. Um, Analogs are, in general, I'll say analogs are useful,
Mhm.
for sure. Um, the problem with analogs is that um, they're what, in a way, they're what we used to call at Boeing a part task mockup. You can only simulate certain aspects, and so you might choose to simulate isolation and confinement of a small crew, even with a communications delay. The Chinese have already done that. Uh, you might choose to simulate operating equipment in mock-up EVA suits. Yeah, there's all kinds of things you can choose to simulate, but you can't simulate any of them fully, and you certainly can't simulate all of them together. So at some point, you need to take the plunge. And I think the game in programmatic planning is to uh, design the threshold above which you're willing to take the risk and below which you need to use all the means at your disposal, including simulations and analogs.
Mhm. Yeah, yeah, that makes sense. Um, yeah, I think analogs are very interesting, also because they allow people to contribute to the science. So MoonDAO supported we're supporting it's called the world's biggest analog.
Hmm.
And I think it's interesting in a way to kind of also engage people that want to
Yes,
find a way to support. It's like a
that's an important benefit, and also, I mean, you almost always learn something
Mhm,
by operating an analog. So in that sense, that they're kind of all good. Um, we were talking earlier about playing in the dirt on the moon, and so here's just an example that I think should be sobering. So half of the lunar regolith by weight is dust, particles that are finer than talcum powder, um, all with sharp edges, right? Because there's no erosion, no water-based or wind-based erosion on the moon, and so they're all just like basically pulverized rock fragments um,
mhm,
from billions of years of meteorite gardening. So it's horrible stuff that no terrestrial simulant has been able to replicate, because it's produced in a way that we can't do on Earth, certainly
yep,
not in bulk, right? So
yep,
you can't make sandboxes or test beds full of stuff that's actual, that has the physical properties of lunar regolith. Without the physical properties, you don't get all the tribological behavior that you do on the moon. Okay,
mhm,
you also can't operate a dusty vacuum chamber at 10 to the minus 12 torr on Earth. You can get maybe 10 to the minus 5 or something like, but you can't get hard vacuum. And so
mhm,
therefore you can't um, truly simulate the intergrain behavior of regolith, nor can you simulate the electrostatic charging properties,
right,
the triboelectric properties. So there's this cascading set of things that you cannot test on Earth, no matter how hard you try. And but you could try really hard. You could spend a whole bunch of money, and try and try and try and build a very specialized dusty vacuum facility with diffusion pumps, with filters and all kinds of stuff. Or you can just figure out how to get to the moon cheaper and equip people with instrumentation and just go play in the dirt there, where we have to do it anyway if we're ever going to do these infrastructure things that we dream about. So just do the learning in situ
right,
is what I would hope for.
right. Makes sense. Um, do you have time for one more question?
Yeah, yeah, sure.
Yeah, okay. So I think it's a good question for us to end on. So Matt's is asking, is there any city or landscape planning being done for the moon? And I'll add my own thing to this is, where are the best resources right now, or the furthest, maybe the groups that are publishing around this subject that are furthest along, that might be of interest to people. Yeah.
So there's a huge bibliography that people can find at spacearchitect.org.
Hmm.
Um, I can't personally vouch for how many of those cited um, publications address city planning or urban planning on the moon. I do know of a couple of papers about it, one of which I wrote back in 2002, um, that start to think about what it would mean to have urban scale developments. Um, there was actually a paper I did in, geez, I guess we published it in 1991, that literally was site planning for a lunar base, based on local conditions and the interactions of the systems and the proximity and anti-proximity relationships among all those things, and with uh, constraints introduced by the prospect of growth, like which directions would you grow things in and all that. So a
Hmm.
little bit of work there on uh, site planning. But at urban scale, um, I would say all the work I've seen is more on the architecture side than on the engineering side. So I saw a chapter in a publication last year, I guess it was, that showed a design, conceptual design for a lunar habitat system that could support indefinite growth. And it, showed this image of something that would support, I don't know, 1,000 people. And immediately my questions go to the programmatic things like, what are the 1,000 people doing? And who's paying for them to be there? What's the export? What's the value? Um, the, the things that lie behind the design concept that, if they were answered, would enable the design concept to be much better informed, much more specific, much more relevant. Um, so, I guess
Hmm.
short answer is there are a few papers out there. I don't think there's very much concerted effort that's gone into that topic yet. And the reason is because we're just so far away from it.
Right. Yeah. But yeah, I mean, hopefully, I mean, I think, well, you see maybe like more of a pessimist. I think that within our lifetimes, we will see the beginnings of a lunar city or a lunar base, and I hope that our dreams come true.
That would be wonderful. Maybe in your lifetime. I'm 2/3 of a century old, so I doubt that I'm going to see it in my lifetime. But if we can lay track, and help guide and accelerate its development, then that's noble work.
Yeah, yeah, I'm very optimistic, just with the progress with some of these AI tools, that we'll be able to leverage them in order to save us a ton of time and engineering effort, and potentially, yeah, some combination of that with the very low cost of access to space as a result of Starship and rapid and fully reusable vehicles. I think that those two things together, um, could mark a massive shift in sort of the inflection point of where we're at. And I don't know. I'm definitely an optimist,
I
but
think they will accelerate things.
yeah.
Um, a question I think everybody should think hard about is, um, what's the purpose?
Hmm.
And science is one thing, but we see the extent of very well-funded science in Antarctica. And it's not a city. There are no cities. There are settlements, and that are sort of intermittent,
Hmm.
population rise, increase and decrease. Um, it's all for research, and so it's all funded by the National Science Foundation in the U.S. and the similar organizations in other nations. So is it about science? And so if it is, then why? How could it ever look different from Antarctica? If it's
Hmm.
about more than science, then we have to answer the question of what is the more. And settlements on Earth that grow into cities are where they are, and they grow the way they do because of commerce.
Yep.
Populations grow because people have families, but the people are there because of commerce. And uh, this is not meant to be pessimistic, it's just realistic. On Earth, you can go pretty much anywhere, and you can breathe the air and drink the water, and you can, you know, plant crops in the ground and stuff like that. You can't do any of that on the moon. It's
Right.
permanently, quickly lethal. And so we really have to think all the time and very hard about why people are there.
Right.
That tells us who's paying for it, how fast they're willing to pay for it, the kinds of stuff we need to develop. And I think, AI might not solve that one. That's sort of a humanistic economics
Hmm.
problem that we need to solve first. But once we know that, maybe it's helium-3. Maybe it's literally extracting material from the moon and exporting it to Earth. Um, I, the risk of delaying us another minute, I did a paper in, I think it was 2017 or 2018, called "Space Architecture for Moon Village,"
Hmm.
and this was at the time when um, the European Space Agency was sort of all about Moon Village and this idea of a place where multiple people could come and collaborate. Um, and I'm like, okay, well, what are the implications for space architecture if we actually did that? And in my thinking in the paper, I rapidly got to where we are now in this conversation, which is, what's the engine of growth? What's the motivation for investing in human habitation in that environment? Um, and I ended up concluding that there was what I called the fast growth scenario, which is very low probability and is based on finding some substance that is worth so much that you can create an export industry. Maybe it's helium-3, I don't know. There's the slow growth scenario, which is um, a kind of gradual accretion of business relationships based on a combination of uses, like
Hmm.
national security or international security, like um, uh, export of specialty materials to Earth, like um, harvesting volatiles from the moon to use as propellant for other things, which, by the way, is what I call a self-licking ice cream cone, because the only people who want that stuff are people who are already operating in space. Um, so there's, I think, slow growth scenario. And then there's the imperceptible growth scenario, which is science. We go and we sort of tootle around and discover stuff and learn things about planetary science and the lunar environment and so forth, but there's no real engine of growth. Um, so that sounds pessimistic. The antidote to that, which is not helpful on the timeline of our lives, but my antidote to that is that I find it inconceivable that 1,000 years from now, humankind will still only be operating on Earth.
Hmm.
It's just not um, compatible with the curious and expansionist nature of humans, I think. So the game is how to, like, if we know that that's the end state, and we know where we are today or where we're not today, how do we build the bridge from now till then? And that's what the growth scenarios are. That's what the attempts at finding resources that are useful are all about. That's what the learning phase, the practicum phase, needs to do for us is reduce the cost and risk, increase the amount of opportunity, and therefore the probability of serendipitous discovery, so that we can learn what are the pathways that connect us to what I hope is an inevitable future.
Yeah, I agree. I think that's a perfect place, and I wish we should continue this conversation in the future. I think yeah, now I'm like wishing we had more time, but I mean I totally agree with what you're saying, by the way, too. The why will define a lot of the eventual kind of form that this all takes, and I think the why is probably the most interesting problem when it comes to going to the moon. But yeah, and I could muse on that forever. But I think uh, yeah, this was amazing. Thank you so much for your time.
Oh, you're
Um,
welcome.
yeah, and you're welcome to stay. We now will transfer over to our Discord, our platform where we can have people within the MoonDAO leadership comment and discuss the proposal. We have one very big proposal this week, which is the budget for the executive branch. So we'll transfer over to there and discuss. Thank you again, Brent, and
You're
yeah,
welcome.
great conversation.
All
Appreciate
right.
it.
Take care.
All right, thank you. Bye.
Cool. Yeah. Thank you so much, Brent. Thank you, Pablo. Yeah, I guess in terms of our agenda, don't go anywhere. Obviously, if you're here watching on YouTube or X, we'll continue, but we will be shifting platforms into Discord once Colin gets it set up in here. There we go. Yeah, I guess, Pablo, so are you? Thank you, Pablo. Yeah, I guess in terms of our agenda, don't go anywhere. Obviously, if you're here watching on YouTube or X, we'll continue, but we will be shifting platforms into Discord once Colin gets it set up in here. There we go. Yeah, we're getting back here from. I thought it was just on mine, but Pablo, do you do
I
this?
was hearing you in repeat.
Okay, sorry. Yeah. Okay, I thought it was just
Oh.
on mine, but okay. Yeah, do you want to take a little break before we get into the proposal that you have and do some project updates first, or what are you thinking?
Sure. Would it make sense for me to just share my screen here to discuss the proposal and jump right in, or easier to just do it in Discord?
Probably easier in Discord since we get
Okay.
questions there too. So,
All right.
all right.
I will hop over there and start presenting. Yep.
Cool.
Okay.
All right. Stick around, folks. We'll get us set up here.
Jump right in, or easier to just do it in Discord.
Probably easier in Discord since we get. Cool. All right. Sorry about that. It was a little bit mixed up there for a second, but yeah. Yeah, we're gonna switch gears here into our project proposals. We have a proposal here for the executive branch from Pablo that we'll get into here in 1 second. I guess just on a quick note, since we are here at the end of the quarter, timeline wise, we do need final reports in from our project leads and senators submitted by Tuesday, October 7th. So that only affects a few of you, but yeah, please make sure to get those in by the 7th. And that also includes community contributions. So anything that you got done on an independent basis related to advancing MoonDAO's mission, be sure to get those submitted into our system by the 7th as well. So you can do that at moondao.com/contribute. And that's for anything over the last 3 months. Yeah, Pablo, if you want to, can you share your screen? You need me to pull up the proposal?
I've got it pulled up here. Just give me 1 second. Let's see. Sorry, I think it might have. I full screened it, so it disappeared here for a second.
Yeah.
Okay, here we go. Sorry about that, guys. There we go. Is this being shared correctly. Can you guys see this? Perfect.
Yep.
All right. So this proposal is essentially it builds on the last 6 months of the executive branch like goals. It's an extension essentially for Q4 of 2025, so this next quarter, all the way through to the beginning of Q2 2026, so 6 months in total. Yeah, so you can view this on the proposal site. If someone can link it, if you'd like to read along with me. So basically, for the past 6 months, we've been working on our core objective, which is the launch pad. So this is a service for the space community at large to finance their projects in a similar way that MoonDAO financed our 2 seats to go to space and the 90 now proposals that we funded as projects. So our core basically the thing that we are focused on the most is scaling the amount of revenue. So the Launchpad will be something that generates revenue for MoonDAO, and it's been something that we've been really focused on getting our first big Launchpad initiative out there. So we've got objectives within this proposal to one, do a 1 month kind of smaller scale Launchpad initiative to I guess this ties into what Brent was saying, but essentially do the practicum and make sure that we don't basically take all those learnings with a small scale thing first, and then move on to a bigger launch. And something that I will point out, which I think is really awesome, is that 6 months ago, our main objective was to achieve a 3-year run rate. So that is scaling revenue, reducing costs, and increasing the treasury size such that the budget is no larger than, on a yearly basis, 1/3 of the treasury. That means that we have 3 years of run rate towards our objectives. And we've actually achieved that, mostly due to the appreciation of ETH and Bitcoin and our treasury management that we've done. But also we've increased our revenue a good amount. I think I have the percent in here somewhere, but yeah, we've increased the revenue up 65% since the last proposal. Pretty solid. We haven't. There's some numbers in here of breakdowns for each of those, so that those include market making fees for Mooney that's being traded. It includes subscriptions for citizens and teams. It includes staking that we do with ETH. And the 2 next big ones are the Launchpad, and then also some of the cross-chain AMM trading fees that we've launched in the last couple months. So this is all good. We still have a ways to go in order to achieve the next milestone is full sustainability, in that like we're default alive. So we're making more than we have in expenses. And yeah, so the really kind of biggest goal that we have for ourselves over the next 6 months, and I'll kind of move into the key objectives and key results, is to increase our ARR to 100K this year. And in order to do that, we need to raise over more than 1 million for an initiative via the Launchpad. And yeah, I think we can achieve this. I think this is absolutely achievable. And once we have one very successful Launchpad raise, and we'll continue upping the ante and continuing to support more and more organizations that are seeking funding, that have something about them that could compel many people to do a crowd raise. So yeah, we are experts in that. MoonDAO's done this successfully. Now we want to basically take all of the infrastructure and use it as a service to other organizations. And then once we have them in our financial system, then we can also support them with governance, incentives, all of the operations that we do at MoonDAO that we've been iterating on and perfecting over the past 3 years. We can apply to other organizations. So that's objective number 1. Which is a big one. Number 2 is, kind of all the stuff we have been doing. So managing the treasury, managing the votes, running the incentive system, doing all the stuff that is required to keep the lights on at MoonDAO. Something that we've kind of identified as a core or a big project here is we want to build our own independent voting table and proposal management software. We, in the past, have been using Snapshot and Nance, and both of them have worked well. But we would like to have an independent capability there, and I think that we'll be able to achieve that in the next cycle. And then that also means that we have kind of more ability to play with how our governance works and have more consistency and uptime in the proposal cycle. Our third major objective is to grow the Space Acceleration Network. So this has been, essentially the core way that we support organizations and individuals is through this network. We want to increase the citizen count up to 250. We did pretty well over the past 6 months in terms of growing the Space Acceleration Network. We'll continue to do so. This also involves a lot of the UI work and website work that we've done. I mean, if you go to moondao.com today, it looks very different than it did at the beginning of the last EB cycle. So we've done a lot of work there to improve the website, improve the dashboard for citizens, and make it easier to do all of the different functionalities that we've kind of like built over the past 3 years. Another part of this objective is to also just work closer with a lot of the teams in the network. We found that we're still learning a lot around like how teams interface with the stuff that we've built. I think there's still a lot of challenges around just the user experience and the UI, but yeah, I think we've kind of improved that leaps and bounds over the past month or two, especially. Things have gotten a lot smoother, so it's looking pretty solid. Our budget is basically the same as it was the last 6 months. There's not too much of a delta between two. We've taken on a part-time intern to support with development. But other than that, we've essentially managed to keep the budget approximately the same. In fact, in ETH terms, it is half the budget of what we had last time because ETH has appreciated quite a bit. So within ETH denomination, this budget is 51.5 ETH, which is less than half of what it was just 6 months ago. So it was lucky that we had the foresight to do budgeting on a smaller time period 6 months ago. Usually we do EB budgets on a yearly basis, but we thought that there might be a chance that ETH does appreciate, and we were lucky. Usually, it's difficult to figure out what's going to happen in the market, but that one paid off, so that's good. That's essentially the 6-month budget proposal for the EB, happy to take any questions.
We have a question here from Elliot in the chat. If you could share a bit more detail on the contingency steps if the ARR target isn't met by the end of the 6 months.
So yeah, we've kind of set as a general. So we have a few knobs that we can play with. One of the knobs is like just reducing overall costs. So this would mean like reducing the size of the team, which would be unfortunate, or just reducing the amount of services that we use, stuff like that, such that we can hit at least a 3-year run rate. So that's, obviously we can reduce costs. I feel, but I don't think that's going to be necessary because I think that, we're pretty much already at like if you look in the proposal, let me go back here to the accounting. Like we're already at 30K ARR, and we only like we need to hit 31 to hit. So like we're like pretty much already there. In fact, our goal of hitting 100K ARR would be even greater than that. So yeah, we're kind of setting our goal to be much higher, and I think it's achievable. The initiatives that we're looking at for the Launchpad right now, I feel I think have a very good chance of raising more than 1 million. I think we have some very compelling people that we're working with. So yeah, but yeah, hopefully that answers your question there, Elliot.
We have maybe some other questions coming in chat, but let me I want to link to the temperature check here channel in Discord for our senators. Please, senators, we have Alex and Mitchie and Phil and Jade and Colin and Iman. So what is that? I don't know, 6 people. But anyways, we need to meet our quorum. We've been kind of struggling with that at times recently, so please do vote and give me a green check mark if you have voted in the temperature check, because we also do have a senator who's in Australia, so it's a weird time, and we might get it might be a bit tight to hit our quorum, I guess. So yeah, Phil's still typing here. Phil, have you seen the impact of the MoonDAO app and other metrics of engagement?
Yeah, it's a good question. I think, well, we have seen an influx of new citizens, which is really cool. I think a lot of that is due in part to the good work Ryan's and Iman and everyone that participated in the Brazil trip, Anastasia, that got a lot of really good press. And I think, yeah, so we've seen a big growth in just overall usage of the moondao.com site as a result of just more citizens joining, which is cool. We have a dashboard via Vercel that has like more kind of granular insights into like how the app is being used. I wonder if we could like publish like reports on that. It would be interesting. But yeah, I can talk to Colin and we can figure out if we can get some of that in the hands of the community.
Thank you. I'm just the reason I asked is I was curious to know if we're like there have been major overhauls. You still had some features you want to develop. I was wondering if the impact of that would be a long-term benefit, or if you're seeing an immediate impact or immediate change in participation.
Yeah.
Or like as an indicator that your feature development's going in the right direction already, or is it going to take a lot more time in order to evaluate the how it's going?
Right. Yeah. Yeah. It's a good question. So I think that less than a month ago was when we launched the new homepage, and even just like over the past like couple of weeks, there's been a lot of changes there. What we really want to do is just consolidate all of the like different things that you can already do within the MoonDAO into one location. And so I think that yeah, it would be good to put together like a report on like how those changes have impacted usage of different features. I couldn't tell you like off the top of my head, like, oh, I guess it's felt like we've had more proposals, but I don't know exactly what the like amount would look like. But yeah, we can we can put together a report around that because I'd be very interested also to know how those metrics have changed. I wish I had a better answer off the top of my head. It's just, yeah.
Well, if we have any more questions coming through, but I am seeing well, 6 people in temperature check, so we need one more person to vote in temp check, hopefully out of our 9 senators. So yeah, hard to tell who's voted or who hasn't. We have different check marks in different spots, so we'll check that you have voted, senators.
We've got in check marks, I see Mitchie, Alex, Iman, Phil, Jade. I guess we're missing Sarah.
Sarah,
She,
Colin,
Colin. Calling people out.
call them out this time because we've failed to make quorum like 2 times recently, so I'm not happy
You got
about that.
7.
All right, we
All
have
right,
7.
got it. Yes.
All right, can stop harping on people. Cool. So yeah, that did pass temp check and should be going up for a vote via snapshot here later this evening. So thank you everyone for that vote. And yeah, anything else, Pablo?
For me, great.
Cool.
Thank you.
All right. Thank you, Pablo. Cool. So yeah, I guess we can do some roundtable project updates. I don't think there's probably anything else to add on the EB side for this week, but who we got in the audience today? Invite Alex up on stage. He's around. Hey, Alex, how's it going?
Hey guys.
Hey, congratulations on the proposal being passed, and welcome aboard as a project and as a MoonDAO senator now here too. Great to have you.
Yeah, thank
So-
you. Thank you all again so much. Really appreciate it and appreciate the like I said, the promotion.
Yeah, I don't know if there's too many updates on your end this time around, but just a call to welcome you up on stage. Normally we do a little quick updates about any developments over the past week, and obviously there's a few outstanding things that we still need to do with you, including making the transfer of funds and probably scheduling a call next week to talk about next steps. But I don't know if you have anything you want to add.
Yeah, absolutely. So this week has primarily been about developing and planning on our team's end for the MoonDAO and ASRI campaign. So it's going to be a multi-tiered, multi-medium campaign across radio, even TV. We do have a couple scientists that will be going on a pretty famous, news and entertainment show that will happen pretty much in the midst of the campaign. So we're looking to get a lot of good visibility there. And then, developing a strong social media campaign content materials. So that's been our focus this week. We will continue with that. We're at T-minus 40 days until campaign kickoff. Scheduled start is November 10th. So whatever support we can drum up in the community, especially for those of you who have a significant level of influence and followers or know other individuals that do. That we could possibly rally your support and get you to repost things during the social media campaign once we launch. That's the kind of momentum we're looking to build here.
Well, yeah, I guess that's a great call to action for everyone tuned in. If you want to help out with this project, help with the rollout of this campaign, obviously, reach out to Alex and see how we can get you involved with it. All hands on deck.
Cool. Thanks,
All right,
guys.
Thanks, Alex. So yeah, I don't think we have any other of our senators here in attendance for a project update. I know IAC is happening right now this week, so I can give a couple updates. Well, Sheepy did post a little video of her talk, I guess, in the What Did You Get Done This Week channel. I haven't had a chance to check it out yet, but take a look there. On the front of the art rocket project in Brazil, I'll just give a quick update here. We do have the Baikonur Attend a Launch contest going on right now. We've gotten, I think, about 7 entries. Some really awesome ideas. Super exciting to see some of the cool ideas that people have that they're sharing with the community in these videos and written format. If you haven't seen them, check them out on socials. I've been posting some in general. I still need to post a few more here that people have submitted more recently. But I mean, regardless of the outcome of the vote that's coming up for who will be sent to the launch on behalf of MoonDAO to see the art rocket launch in Kazakhstan, some of these project ideas are really cool and should definitely be explored further in ideation and see if we can develop them into a real MoonDAO project. So yeah, again, the deadline is coming up here, basically end of day. So if you're interested in participating in that opportunity, definitely check out the link, moondao.com/artrocket, and get details about what you need to do. But it's a brief written statement and a 2 to 3 minute video posted on socials. I'll just share the link here. Phil, did you have something about the IC paper, or is it something else?
Something else.
Okay. 1 sec. And then I guess just in terms of the WBA or WBA project scholarships, still working with Bob to get out the scholarships. He has a little small contract that's being signed between the recipients and MoonDAO, basically to ensure that they're going to be participating in the WBA. If not, they'll return funds. I think 3 out of the 10 people have signed that so far, and just trying to track down the last bit there and get those out to people hopefully next week before the quarterly cycle closes up. So yeah, that's the latest I have there on the WBA. Cool. I guess we can open up for a very brief open floor. Phil, did you want to share something?
Yeah, a past project I wanted to update the community on more things that are happening. We bought an atomic clock last year. It went a student project. Next week, I'll be presenting it at the conference for clock synchronization for the IEEE. And then I'll be giving a talk about it for the Open Compute project, which is the link I did here. So yeah, it's our project in action. This is MoonDAO's clock.
Awesome. That's cool to hear. Also, I guess that's a good point too, Phil. You can add this to like the event calendar here in Discord, and it'll pop up to populate to other people too. But yeah, we'll try to share the word here about this event as well. So cool. Yeah, once again, senators, bear in mind that the final reports are due October 7th, so please be sure to have them submitted by then. You can make small revisions to the final reports up until the 9th, but I have been in contact with everyone kind of individually. More importantly, get in your community contributions, any kind of independent non-project work that you've been doing that helps advance MoonDAO's mission. You can submit that and get rewarded with a small amount of ETH and some more voting power. So these are great ways to just keep building up your presence here in MoonDAO, getting some more voting power and helping contribute to build our multi-planetary future. So yeah, next week at the same time, same place, we'll be doing the final reports, our live kind of demo day of the projects. Everybody showing what they've built, what they got done over the past quarter, presenting their efforts here to the community, and the community will ultimately decide, any retroactive awards that go to each of those projects. And yeah, we do have one vote that's still open right now, which is the change to the project system. It closes in about 20 hours, I think. So if you haven't voted yet on the proposed changes to the project system, please do get your votes in here in the next 20 hours or so. So thank you everyone for joining us today for the awesome talk with Brent. Really interesting, a lot of food for thought there, and for the new EV proposals. So cheers everybody. Thank you. We'll see you next week, same time, same place for demo day. Peace.
Welcome to MoonDAO, a revolutionary governance model and mission-oriented community that's reshaping collaboration in the space industry. Our mission is to create a self-sustaining, self-governing settlement on the Moon to act as a launch point into the cosmos. MoonDAO is governed like a nation, with its own economy, constitution, voting system, treasury, elections, and senate, but internet native, and so without the limitations of geography. In 2022, we sent our first member to space, showcasing our model's capacity for real-world impact. Now, we're implementing key solutions for global collaboration in the space industry. We offer a borderless, permissionless platform that enables everyday people to participate in the future of space development and exploration. Be part of our lunar legacy and join the MoonDAO movement today.